Hello, my name is David Reyes. This is the first video about digital communications. So, to start off, I will be defining what communications is. And basically, it's imparting or exchanging information between two entities. Animals, humans, everyone needs to communicate, but especially us, we need them to be reliable, we need them to be economical and efficient. If we go more to the telecommunication context, communications basically take place by passing signals between a transmitter and a receiver. These communications can be done over wire. We can think about a phone directly connected to a central station. This station connects to the other phone in our house. So this is a wire connection. The other way to do this could be through optical fibers. We would need a modem connected via fiber to another modem. And the last option could be wireless communications, for example, a cellular communication, where we have a tower which will be transmitting signals over the air through electromagnetic waves towards a receiver. Okay, so now, so an important objective in the design of a communication system is often to minimize equipment cost, complexity, and power consumption, whilst also minimizing the bandwidth occupied by the signal or the transmission line. Bandwidth is the measure of how rapidly the information-bearing part of a signal can change, and is therefore an important parameter for communication system design. The efficient use of bandwidth and transmission times ensure that as many subscribers as possible can be accommodated within the constraints of these limited and therefore valuable resources. The components of a digital communication transceiver are shown in the following graph. We have the transceiver, which it's nothing more than a transmitter receiver. We can see here in this graph that in the top, this section here is the transmitter, and at the bottom are the receiver components of the transceiver. There are two main blocks, which are the codecs and the modems. Codec stands for coder-decoder, and modem stands for modulator-demodulator. Each one of these blocks and its sub-blocks will be covered in these series lectures, and we will analyze each one of those. Right now, I will give a very brief description of each one of those. A codec, at its simplest, consists of an analog to digital converter. The ADC consists of a sampling circuit, a quantizer, and a pulse code modulator. The sampling circuit provides discrete voltage samples taken at regular intervals of time from the analog signal. The quantizer approximates these voltages by the nearest level from an allowed set of voltages, whereas the PCM encoder converts each quantized level to a binary code word, digital ones and zeros, each being represented by one of two voltages. The anti-aliasing filter here at the beginning, what does is it's included prior to the sampling in order to reduce the distortion which can occur as a result of sampling process. Now, at the receiver, the opposite to the ADC, it's the DAC, which is the digital to analog converter. Its components are the reconstruction and the PCM decoder. Basically, the DAC received binary voltage pulses are converted to quantized voltage level by the PCM decoder, which is then smoothed by a low-pass filter to reconstruct the original analog signal. The digitization of analog signals usually increases the signal's transmission bandwidth, but it permits reception at a lower signal-to-noise ratio than would otherwise be the case. This is an example of how one resource bandwidth can be traded off against another resource, transmitter power. So the codecs may widespread use of sophisticated digital signal processing techniques to encode efficiently the signal prior to transmission, and also to decode the receiver signals when they are corrupted by noise, distortion, or interference.